Okay, just a quick recap on chapter 4, periodic table. Okay, so periodic table. Okay, first one, make sure you are okay with the all the scientists and all their contribution, okay, into the development of atomic structure. Okay, so all that baca je lah, just keep in mind they could come out in paper 1, very famous question in paper 1. So just keep in mind the scientists who contribute contribute to the development of atomic structure. Okay, alright. I think paling-paling pun macam if you susah nak ingatkan, we have like 3M. 3M. Okay, 3M is what? We have, first one is we have Moseley, and then we have Mendeleev, and then we have who? Mayer, kan? Okay, so sekarang ni just ingat dia punya keyword je. Okay, I'm not saying that ada 3 scientist, sebenarnya ada 7 or 8. Okay, I'm not sure, you just buka textbook and just read. Okay, so but there are 3 yang you always get confused with, kan? So 3M, Moseley, Mendeleev and Mayer. So Moseley first. Moseley dia arrange table using what? Proton number or atomic number. Okay, while Mendeleev dia arrange table, but then they use the mass. Okay, and Mayer just plot graph. Okay, so just take the keyword. Alright, now in this chapter kita tak belajar semua in periodic table. We only learn group 18, okay, group 1, group 17, period 3, and also transition element. Okay, so I hope you're okay with the basic as to macam can say like punya all the nicknames, like group 18 they call it noble gases, kan? I hope you're okay with that, and so on and so forth. Okay, alright. One thing that I need to highlight is whenever they say about contohnya group 18 lah, okay, for example group 18, what always come out for group 18 is they ask for dia punya appearance. Okay, so group 18 punya elements they appear as, first one is colourless gas. Okay, later we'll see some question. Colourless gas, and also dia exists as monoatomic gas. Okay, monoatomic means one gas with one atom. Okay, so this one I need to highlight. Okay, so now popular question would be dia tanya why noble gas exists in monoatomic form. So you need to know that, let's say lah, I give you an example. Let's say we have sodium. Sodium is the electron arrangement is 281, kan? So the one is kita buat apa? Kita donate. Why do donate? Sebab dia nak reach 8 octet. Okay, alright. Then I give you an example for monoatomic gas. Let's say we have neon. Okay, neon, the electron arrangement is 2.8. Okay, so 8 ni meaning dia dah what? Stable. Okay, stable. So they're special, meaning they are dah memang exist secara stable. Meanwhile all the other elements like group 1, group 2 and so on, semua tak stable, and they have to donate or receive to become stable. Okay, so if question asks about why noble gases exist in monoatomic form, you have to answer all noble gases. Okay, this is very strict in terms of you cannot say they cannot, they're not human, kan? They cannot, you katalah all noble gases have achieved stable octet or duplet electron arrangement. Okay, must state this next sentence. Okay, so what? Noble gases will not donate, receive, or share electron with other atom. Okay, alright. Next thing I need to point out is about ni generally lah. Okay, so untuk group 18 memang dia tak reaktif, bukan? This why dia tak reaktif, because dia dah stable. Okay, so for group 1, 17 and 3 and period 3 no lah. This one use a different understanding. Okay, this one you need to know the melting and boiling point, the trend going down the group, okay. Maksudnya in terms of dia punya melting point and boiling point, and also conductivity. Okay, just to recap, let's recap a bit on group 1 punya melting and boiling point. Okay, so group 1 ni, melting and boiling point ni, kita boleh tengok in terms of what type of element it is. It is metal, alkali metal kan. Okay, jap, let's do few example. Lithium 2,1, sodium 2,8,1, potassium 2,8,8,1. Okay, so as you go down the group, you see the size of atom increase. First one is size increase, size of atom, atomic radius, you can see that. And then you can say density also increase kan. Okay, and okay, this one we want to discuss melting and boiling point. Okay, so the melting point decreases. Okay, decreases. Why? Why decreases? Okay, so you don't need to hafal pun sebenarnya, just draw. Draw orang lidi ni kan. Let's say this is lithium with lithium. Because lithium is small, so I draw it as small. Okay, so kita differentkan dengan potassium. Potassium have big head but small body. Okay, big head but small body. Okay, so now why big head small body? You kena tengok dia punya the first 3 shells are fully occupied. So look at it this way, macam atas ni dia big, but then the last shell only 1 electron. So meaning towards the end dia kurus lah macam tu. Okay, now after you draw like that, okay, fikir what is the bond? So the thing that holding them is what we call as metallic bond. Okay, metallic bond. Alright, so now if they ask why melting point decreases going down group 1, so you say first one is the what I cakap lah, atomic size just now increases. Okay, so kalau you tengok atomic size, okay, so I ask you between lithium and potassium here, okay, if they were to fall on their side kan, which bond would break off first? Potassium or lithium? So you think like, oh, potassium is heavier, it's bigger, so the metallic bond is more likely to break first. Faham so dia akan putus dulu lah kan. So now kita boleh kata the metallic bond is getting weaker. Metallic bond weaker, meaning kalau dah weak, less heat required. to overcome the force of attraction. Okay, alright. And then it's different with group 17. Group 17, okay, talking about the melting point and boiling point, okay. So kalau group 17, okay, let's do example lah, okay. So we have fluorine, chlorine, bromine and iodine, okay. So the electron arrangement is 27, 287, 28, 187. You don't need to hafal, no need to hafal, okay. Given, will be given, okay. So now you can see that moving down the group, size is getting bigger, okay. Size increases, okay. Density increases, okay. I'm going to go straight to the melting point, boiling point, okay. So now blah blah blah, okay. You can see the boiling point increases. Why? Okay, so kita lukis fluorine, okay. Fluorine is small, and iodine is big. But then you see, I'm going to draw big head, big body, big head, big body, okay. Okay, why sekarang big head, big body? Okay, you see, so the first 1, 2, 3, 4, first 4 of the electron shell, the shell is filled with electron, so we have a big head, and as you can see, the outermost shell is also almost fully filled lah, kan? Almost full, fully filled almost full with electron, okay. So now you can see that it's pretty gemuk jugalah, okay. So now you can draw your bond, okay. So now the bond is strong in this one, because why? Because they macam they ikut like the size of the body also, okay. So if the size of the body is small, then the bond is weak, okay. Now you can see that this is non-metal, so non-metal we call it as van der Waals force, okay. Okay, bila kita jumpa lagi, van der Waals force is in covalent bond, okay, covalent compound, okay. So now can see, so now let's see the question asks, why the boiling point increases going down the group, okay. You can see moving down group 17, atomic size increases, so the van der Waals, please write full, okay, in your exam. Van der Waals force become stronger, okay. And then kalau dia strong, meaning more heat required to overcome the force of attraction, okay. Alright, that's it about melting and boiling point, okay. As you can see, sebenarnya whenever question asks about melting or boiling point, kalau you perasan lah, we have 3 things that we have to write sebenarnya. The first one is we have to say the name of the force of attraction, and then the strength, okay. And then how much heat required to overcome the force of attraction, okay. So 3 things: name of force of attraction, strength of force of attraction, and how much heat required. Again, tengok I highlight, okay. So the name of the force of attraction is van der Waals force. Ni strength, more heat is how much, see. Ni pula name of the force of attraction, strength of the force of attraction, how much heat is required, see. 3 points, so you will get full marks, okay. Next, let's talk about reactivity. Let's do group 1 first, okay. Now when we talk about reactivity, we have to think of nucleus. What's nucleus doing? What's nucleus doing? Okay, so now nucleus dia buat apa? Dia pull electron towards the center, towards it lah, because nucleus is in the middle. Okay, now faham Now group 1, they tend to what? Diorang punya electron arrangement is 2 1 2 8 1 kan. So we can say that they what? They donate kan? Donate. So they become stable. Okay, so the concept is the easier to donate, the more reactive. Okay, so now if we were to draw lithium punya electron arrangement, okay, I'm going to compare only two lithium and potassium only. Okay, alright, let's see. If we were to draw lithium, okay, I'm going to draw small. 1 2. Okay, and then potassium I'm going to draw a bit bigger. 1 2 3 4. Okay, alright. So ni okay lah, 2 8 8 1 and blah 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 blah. Okay, 2 8 8 1 ni 2 1 and ni 2 8 8 1. Okay, alright. Now, so remember the concept, the easier to donate, the more reactive. Okay, so going down the group, moving down, kalau you perasan, the electron is the outermost shell is further away from the nucleus. Okay, so you think, just now we say, what's nucleus doing? Nucleus, they pull electrons towards it. Okay, so nucleus is in the middle. Okay, here our boy nucleus kan. So now tell me, which one is easier to pull, lithium or potassium punya nucleus? Which one is easier to pull? Which one doesn't have to work as hard? Lithium, right? Because the distance is shorter, much shorter. Okay, so we can say lithium can pull stronger, macam tu. Can pull stronger, maksudnya dia won't let go the electron as good lah kan. Dia won't let go the electron, so won't let go electron. This is the concept. Jangan tulis macam ni, won't let go electron. Okay, so you write in chemistry punya words. Okay, now you can see, okay, moving down the group, okay, kan, what happened? The valence electron is further away kan from the nucleus. Okay, so maksudnya bila dia jauh, you can say that the force is not as strong kan. So the force of attraction, this is what we call force of attraction between nucleus and valence electron become weaker. Okay, so maksudnya easier to let go kan, easier to let go electron. Kalau potassium lah going down. Okay, so macam lithium and potassium, lithium ni lagi strong and dia tak nak let go. So potassium nak let go, senang let go because the force is not as strong. So easier to donate electron. Okay, moving down the group lah. Moving down, ni trend. Okay, donate electron, so more reactive. Okay, so now if you want to fikir untuk group 17 kan, sama juga the concept. Now group 17 is, let's see, 27, 287 kan, dia nak electron, want to receive electron. So easier to receive meaning more reactive. Okay, so now let's see. Let's see, kita just use two example. Okay, two example. Alright, so fluorine and chlorine. Okay, fluorine small, chlorine big. Okay, oops. Contoh. Okay, so now between fluorine and chlorine, okay, which one is more reactive? Which one is more reactive? So dia fikir, oh, now okay, let me draw the outermost shell punya electron. Okay, you can pause this video and you can guess. Okay, alright. So the answer is fluorine is more reactive. Okay, more reactive. Why? Kalau fikir, going down the group kan, moving down the group, dia guna tadi what? Valence electron further away from nucleus. So the force of attraction between nucleus and valence electron is weaker. Okay, sambung. Cannot what? Cannot pull electron as strong as cannot pull electron, ataupun harder to receive electron. Cakaplah formula lah. Okay, harder to receive electron kan. Kenapa? Moving down group so maksudnya less reactive. Okay, alright. So kalau you perasan sebenarnya when you want to talk about reactivity, okay, reactivity, dia kena cakap pasal apa? Satu, going down, how the size kan, the size kan, so the atomic size. And then kalau size ni can elaborate, cakap the distance between what? Nucleus and valence electron. So talk about the force of attraction between what? Between nucleus and valence electron. Is it what? Stronger, weaker, the strength. Okay. Number 3, you say easier or harder to what? To donate, to receive. Macam tu je sebenarnya. Okay, very easy one. Okay, so for a transitional element, it's very easy sebenarnya. They won't ask a lot. Okay, transitional element sebenarnya tak banyak pun. Okay, they would ask about first one lah, paling famous lah. Dia suka tanya pasal the size. Okay, so you can see that sodium, magnesium, aluminium, silicon, phosphorus. No need to memorize. Okay, chlorine and argon. Okay, moving across. I'm talking about transitional element. Sorry. Okay, terlalu rushing. Transitional element is the one yang this one kan. Kat mana? The one in the longkang. Okay, here. Alright, now kalau you nak kata pasal kalau any question lah, tanya pasal transitional element, jangan risau, dia would only be 2 question. Akan tanya 2 soalan sahaja. Okay, 2 question only. First one, they would ask about what is the physical property of transitional element. Tu je. Ni first question. Okay, question 1. So transitional element ni, kalau nak tahu, dia ialah metal. Okay, metal. How do I know that it's metal? Okay, we have group 1, group 2, and then skip kan, 14, 18 kan. Okay, sebenarnya dekat longkang ni is 3 sampailah Okay, now sampai 12 sebenarnya kan, sampai 12 kan. So now kat sini kita boleh nampak, kalau ingat tak I've mentioned about metal, dia group 1 until 13, non-metal pula 14 until 18. So transitional element duduk between what? 3 and 12. Group 3 and until 12. Until 12. So maksudnya dia belong dekat mana? 3 and 12 ni dalam inside here, tak in between here. So maksudnya transitional element ni ialah metal. So dia punya physical properties follow sahaja physical properties of metal. Okay, the first one is, you can see it has good conductivity for heat and electricity. Okay, and then you can see that it's shiny, solid. Number 3, you can see it's denser than water. Okay, and then the melting point and boiling point is high. Okay, and then there are 2 other properties. This one, I star. Okay, it is ductile and malleable. Okay, second question that could be asked in transitional element ialah the special characteristic. What are the special characteristics of transition elements? Okay, so first one, we have they have multiple oxidation number. Oxidation number. Okay, this one contohnya macam, we know that iron, we have Fe2+, and also what? Fe3+, kan? So I'm saying, kalau other elements in group lain, kan, let's say we have sodium, contohlah. Let's say sodium, kan, ada ke Na2+? Tak ada, kan? We only have Na+, je, kan? So now only elements in transitional elements sahaja yang akan ada multiple oxidation number. Okay, so sekarang ni sekejap, highlight. Okay, this one is element dalam transitional element. Kalau yang sodium ni is in group 1. Nampak tak? So we can see the example here, kan? Alright, next is they can form complex ion. Can form complex ion. Okay, so contoh I give you yang biasa you nampak, which is Cr2O7 2-. Okay, so this is dichromate ion. Okay, so you see dalam one ion, this is ion, an ion, kan, satu ion, and they have chromium and oxygen, what we call as polyatomic ion, and this is complex ion, kan. So only transitional element yang boleh form complex ion. Okay, so macam let's say like just now Na+, kan, Na+, mana ada like Na H2O ada 4, and then it's still an ion, kan, tak ada. So other groups cannot do this. Okay, cannot do this, tapi transitional element can. Okay, they can form complex ion, manganate, kan. So which one the transitional element? The chromium, the manganese, kan, Mn. Okay, this is an example. Okay, and also they can form colored compound. Okay, can form coloured compound ni macam you know that Fe2 plus how it's green kan, Fe3 plus how it's brown kan. So other elements in other groups kan cannot do this kan, diorang ada all the boring colour like greyish semua. Okay, so last one is they can act as catalyst. Okay, catalyst. Alright. Okay, that's it untuk transitional elements.